heavy elements that we find on Earth were originally synthesized, that's all the heavy elements that we find on Earth were originally synthesized, that's made, inside stars. Astronomers are now studying the mechanism in which these elements are formed inside the stars. Now they know that somewhere in the universe there will be every element, or at least the ones that are not radioactive, inside different stars. But the problem is to detect a particular element in a star. And some elements, like the element tellurium, had not been discovered in stars before. Now, just to remind you, I need to put a glove on here. Here is the sample of tellurium. In fact, there are two samples. There's one here inside this block, and there's a rather nice bell-shaped piece. And you can see that tellurium, when you look at it on Earth, a large lump, looks rather like a silvery metal. It's not a metal, it's so-called semiconductor, but it shines rather like a metal. The reason why I'm using a glove is because if you absorb tellurium in your body, it gives you terrible smells coming out of your body, which I don't want, and you probably don't either. I can pick up a lump like this, and in principle I can do analysis and show it's tellurium. Brady found a recent press release here from MIT, Massachusetts Institute of Technology, announcing that some of their astronomers had discovered evidence for the existence of tellurium in a star. Now, the press release was clearly not written by a chemist because it begins rare earth element found in far, far away. And tellurium is not a rare earth, but we can forgive them that. And there's a paper which talks about detection of the second R process. R stands for rapid peak element, tellurium, in metal-poor stars. This is a physics journal, so I don't know the meaning of all those things, but the actual experiment they did is quite easy to understand. Now, as you can guess, the only thing that you can measure easily from the star is the light that is coming from it. You can't travel there with your test tubes. What the basis for this experiment is that every element will have a characteristic fingerprint of the wavelengths of light that it can absorb. So you can look at a little peak of absorption and say, that's tellurium, or that's chromium, or that's iron. Now, unfortunately, for this particular experiment, the region in which tellurium absorbs is very short wavelength ultraviolet light, round about 230 nanometers or 2,300 angstrom units. This is a region where the Earth's atmosphere absorbs. So the crucial light that you need to detect tellurium is absorbed in the atmosphere, so if you point your telescope from the ground at the star, you just can't see anything. You can't tell whether there's tellurium there or not. So what they did was to use the Hubble telescope, which is out in space, so there's no air in the way, and so they can look at the stars without worrying about the absorption. Here is their spectra from 3 different stars, and this is the wavelength round about 2,385 angstrom units. So you can see there's a really tiny, tiny piece of the spectrum here, and these peaks here show where light is being absorbed. And you can see there are a lot of them. It's like looking for a tree in a forest. And there are 3 of these because they're from 3 different stars, which have these rather unromantic names of HD and then a lot of numbers. The important peak is here. You can see it's not very big, but that peak there convinces the scientists that they have found tellurium in the stars. Now, from the point of view of chemistry, this is not terribly important. Chemists are only interested in lumps of tellurium and using it to make chemicals. So the fact that it is in stars that are so far away that nobody could possibly ever travel there is an interesting fact for the coffee room, but it's not something that is going to lead to a whole new area of chemical production. On the other hand, the more we can understand about how our universe originated and how the elements originated is valuable. It's a very good test of the theories of how elements are formed and so on. And the aim of science is to try and improve the picture of the world or the universe we live in. And it's never finished, because once we have got the broad outline, there are always details to be filled in, and sometimes those details will show that theories are wrong. A lot of scientists, even if they're not astronomers, are fascinated by astronomy. I'm quite interested by it, but I feel so sick and get such big headaches when I look through a telescope that or field glasses, that I've never really done much astronomy. But it is a very sobering thought to realize that there are these enormously complicated processes that have occurred millions of light years away, billions of years ago, that have created the chemicals that we're using today.
And if you want to find out more, you can go to